Good morning, everybody, and welcome back. I hope that you all had a great winter break. I hope that you were able to take some time to relax, to enjoy yourself. And so we're going to go ahead and get started with what we're going to be learning with for the first couple of weeks here. And so what we're going to be talking about is we're going to be talking about financial mathematics. So we're going to be talking about kind of the math involved in some of the money decisions that you will have to talk about. And basically the reasons we're going to be going over this is because at some point in your life, you're usually going to need to invest or borrow money. And so with that, let's get some terminology down real quick. So if you're borrowing money from somebody, we're referring to that as the principal. Like whatever amount is borrowed, the initial amount, that is going to be your principal that we're talking about, or the initial amount invested. And the way that lending money works is that typically if someone lends you money, they charge some sort of interest rate as a fee for borrowing that money. So like it could be like a 2% interest rate, a 3% interest rate. It could get higher depending on how you're borrowing that money, or lower. And so whenever you're paying that money back, you've got to repay the principal as well as the interest charge. So you always end up paying back more than you borrowed. So with that, the amount that you pay back in interest depends on a couple of things. It depends on the principal, it depends on the interest rate. It also depends on the time that the money is borrowed for. So we're also going to talk about this concept today of compound interest. And so basically what compound interest means is when you get interest on your interest. So whenever you deposit money into a bank, it will usually earn compound interest after a certain time period. So like let's say if it compounded every month. So after the first month, you're going to get paid a little bit of money if you have it in a savings account. And then the next month, the money that gets lumped onto a sum will also make you some interest, and so on and so forth. And so Mr. Price had a little bit of a brain fart when he was doing the compound interest stuff. So what we need this stuff here. This is what we're referring to as that compound interest formula. And so if you look, it looks pretty similar to the growth formula that we were talking about. So we've got U sub 0, the initial amount, the principal. We're going to multiply that times 1, which is representing 100%. We're going to add that to the interest rate divided by the number of compound periods. And then we're going to put that to the n times t, to the number of compounds times the time. That's how many times we're going to get interest on that. And so we're going to look at some examples today of some compound interest, as well as a little bit of inflation. So the first example we're going to look at here. So we're investing $5,000 for 4 years at a 7% interest rate here now. And so we're saying this is going to be compounded annually. And so we want to know, okay, if we invest that money, what is it going to be at the end of this period after 4 years? So what we're wanting to find here, we're going to say U sub 4. So this is 5,000, and we're going to multiply this by the growth factor here. So this is going to be 1 plus, so R, the interest rate here, if this is 7%, we need to remember that is R is 0.07. So 0.07. Now the thing is, if this is being compounded annually, the value of n there is just going to be 1. So we technically, mathematically don't even have to put it, but for the context, I am going to. So we're effectively going to be adding 5,000 times 1 plus 0.07. So we're going to multiply 5,000 times 1.07, and then we need to figure out how many compounding periods are there. So if it's compounding annually for 4 years, N here is going to be 1, T is going to be 4. It's going to compound a total of 4 times. So really, 5,000 times 1.07 to the fourth power is what that is. And it makes sense if you think about it. If it's gaining 7% per year, we're going to have to multiply by 1.07 4 times. So let's see here. That is going to be $6,553.98. And so when I'm sure this goes without saying, when you are working with money, we throw the 3 sig figs out the window. We round to 2 decimal places because we work with cents. So then the second question here is asking us, okay, how much interest has been earned from investing this right here? So think to yourselves real quick, how would I calculate that interest? So we're going to take this final value and we're going to subtract that initial value. So we're going to say $6,553.98. We're going to subtract the initial $5,000, and that's going to give us $1,553.98 there. So to start, it's just an extension of that growth that we were talking about at the end of last semester. So we're going to look at a couple more problems involving this, and then we're going to talk a little bit about inflation. So on the second example here, we're investing, so this symbol right here, we're talking about pounds. So we've invested 5,000 pounds, is invested at 4 years at 3% interest compounded. Now the thing is here, this is quarterly now. This is no longer annually. So we want to find the value of this investment at the end of this period. So I'm going to jot down the formula right here for compound interest just to help you all out a little bit as well as help myself out. So here we're given some information. So we want to find, so again, we're investing for 4 years. That seems popular. So we're going to find U sub 4. So we're investing $5,000. Again, that seems to be the amount to invest nowadays, or at least in Mr. Price's world. So we're going to say 1 plus, so 3%. Again, that means that R here is 0.03. Now, here's the thing with the compounds, though. Quarterly, that's going to mean, so think to yourself real quick, how many quarters are in anything? And you're probably saying, oh, there's 4 quarters in $1 or an NBA game or in anything, because quart means 4. So we're going to take that 0.03 that we're supposed to get for the entire year, and that's getting divided by 4. And the compounding periods, and you're probably like, wait, Mr. Price, well, if it's getting cut by 4, am I going to make less money? Well, the thing is that also, this is N times T. The amount of compounding periods is going to increase. So T is still 4, still 4 here, but also N is 4. So our exponent is going to increase as our interest rate is decreasing because we're getting it quarterly. So we're going to say U sub 4. That's going to be 5,000 times 1.0075, and that's going to be to the 16th power. And if we evaluate that, we're going to get that the fourth is going to be 5,634 pounds and 96. I think it's pence, but I don't know if I'm not very familiar with the British system. I can barely draw this pound sign. I apologize, you all. This is a monstrosity. I clearly need to study up on British finances. So you can see there, if you compare that to our answer from the first example, that the amount of interest, a couple of things that changed were the compounding and the interest rates, and we're making about $900 less. So that both of those, typically the more compounds you have, the more money you will make, and the lower interest rate, the lower interest rate that you will make. So we're going to look at one more example, and then we're going to turn it over to some inflation. So what we want to know now is how much does Ivana need to invest now to get a maturing value of $10,000 in 4 years' time? Given she's going to have 8% interest compounded biannually, and we want to give this answer to the nearest dollar. To the nearest dollar here. So we're still working with this up here, and they tell us that we want to end up with $10,000, and we're trying to find how much we need to invest. So we're going to write this out. We're going to say 10,000 equals u sub 0. We don't know what that is. We're going to say times 1 plus 0.08. It's biannually. So real quick, think to yourself, biannually, what would that mean? So that's going to be a compound period of n equals 2. So we're going to divide that by 2, and then we're going to do 4 years again. That seems to be the popular one, times 4. And so now what we're trying to find here is what is the amount of principal that we're going to need. So we're going to have to isolate that u sub 0. So to do that, I'm just going to simplify some of this stuff right here real quick. So 0.08 divided by 2 is 0.04. This is going to give me 1.04 for this particular one. So 2 times 4, it's going to be 8 times u sub 0 equals 10,000. And so really, since these things are multiplying, all that we're going to do is divide both sides now by 1.04 to the 8th power. And so I guess I'll pull out a calculator to figure that one out. Let's see, Graphing Calc 84 divided by 1.04 to the 8th. So the initial amount of money that you would need, if you're going to need it to be $10,000 in 4 years, if that's what you're wanting, is, and let me check here. We're supposed to round the answers to the nearest dollar, because that seems like a really awkward amount of money to invest. People typically invest whole dollar numbers, so we're going to round that up to $7,307. So if you invested that amount of money with an 8% interest rate, it would give you, it would be worth $10,000 in 4 years. And so there's a lot of different reasons to invest, but amongst other things, there's something called inflation, which is typically a pretty good reason to invest. And basically what inflation is, if you're not familiar with it, is that there's usually a set rate that stuff increases by or decreases by in worth per year. So inflation is the general increase in price of goods and services over time. And basically what this means is that like $1 this year won't buy you as much stuff as $1 next year. It reduces the purchasing power of your money, because it's going to buy less and less stuff as the value of stuff continues to go up. And so whenever you're making investment or savings goals, inflation is something that needs to be accounted for, because the money that you have today isn't going to buy as much stuff as it would from a year from now, which is, and inflation's a whole other thing. You can look it up if you're really interested in it. It's kind of interesting to me the way that they choose to do it, but I think it generally works. So whenever you need to find the future cost for when you're trying to set these goals, you have to do something that's called indexing for inflation. And basically all that indexing for inflation is that you're just going to multiply the principal by the rate of inflation. And we'll look at what that looks like mathematically here. So in this example here, we've got Georgia would like to purchase a painting currently worth $5,000. Everything's worth $5,000 in this book. I don't know what's up with that. So she's making monthly deposits into an investment account so she can purchase this painting in 3 years. So if inflation is going to average 2.5% per year, we want to calculate the value of the painting after inflation here in about 3 years. So we want to figure out, okay, I don't have the money to buy this right now. When I do want to go buy it, how much am I actually going to have if this inflation is 2.5%? So when we're doing that, I ran out of room here, so I apologize about that. So when we're doing that, all we're going to say is, okay, well, if the original price of this was $5,000 and it's increasing 2.5% per year, and we want to buy it in 3 years, we're basically going to use that growth formula, or you can just use the regular, I guess, compound interest. They don't really give us a compounding period. I guess we could assume annually, but we're looking more so u sub 0 times 1 plus r to the n, and the rate here is going to be, we're going to have to divide that by 100%. So the r is going to be 0.025. And so mathematically, this makes sense if you say, so u sub 3, we're trying to find the value in 3 years. We're going to do 5,000. It's going to increase. We're going to add 0.025, so that's going to be 1.025. It'll have 102.5% of its value. And we're going to put that to the third power because it's going to inflate by that percent for 3 years. So then all that we've got to do is figure that out. So let's see here. Mr. Price, he is sharp with the mental math, but he is not that sharp with the mental math. 1.025, oh, I'm messing up, times 1.025 to the third power. That is $5,384.45. We're going to round that there. And so even though right now the painting is worth $5,000, if inflation is 2.5%, we have to account, if we can't buy it just yet, how much that's actually going to cost us. So that would be the actual cost of it when you go to buy it in 3 years, assuming that inflation. So with inflation, knowing this, so there's something that's called the real value of investments. And basically, to find the real value of an investment, so like when you make an investment and you do these calculations, you're going to say, oh, well, I'm going to have this much money in 10 years. You need to calculate how much that's actually worth. So calculating the real value in today's dollars. So basically, to do that, what we're going to do is we're going to divide it by its inflation, by the inflation multiplier, rather. So we're going to look at one last example, and then we're going to be good for today. So here, oh, they're investing a different amount of money than $5,000. That's refreshing. So here we've got Gemma invested $4,000 into an account for 5 years at 4.8% interest, compounded half yearly. Inflation averaged 3% per year during this time. So with that, the first thing that we want to do is calculate the value of the investment after 5 years. So let's see, u sub 0 times 1 plus r over n to the nt. So the first thing we're going to do is just calculate the actual value. So to do that, they're investing $4,000. That's the initial amount times 1 plus, so 4.8 0.08 here. That's our value of R. That's going to be 0.048. So 0.048. Now, if this is being compounded half yearly, that's just a weird way of saying twice a year. So we're going to divide that interest rate by 2, and we're going to multiply the number of compounds, 2 times 5 years here, t equals 5. And that's going to be what U sub 5 is going to be. So then to calculate this, what we're going to do is say, okay, 4,000. Let's see, that'll be 1.024 to the 10th power. And then we've got to do just a little bit of math to figure that out. Just a little bit. And Mr. Price, as great as he is at mental math, has no idea what that's going to be. That's perfectly fine. So I'm just going to punch it into my graphing calculator real quick. So that's going to be $5,070. And then 0.60 cents. So that's how much it will be worth in 5 years. It will have roughly increased 25%, which is pretty good. But the thing is, while Mr. Price had this investment going on, inflation was there as well, and it was going after Mr. Price's money because the general price of stuff goes up. So what we've got to make sure when we are finding the real value, all that we're going to do is we're going to divide this final number we get by the amount that inflation was during this time. So inflation here was 3%. So that what that means is that each year things increased by 3%. So that means that our inflation factor here, what we're going to have to be like multiplying or dividing by, is going to be, so it's going to be 103 out of 100, which is 1.03. This is our inflation factor here. So we're going to say $5,070.60. That's going to get divided by 1.03. But the thing is, we've got to divide it by 1.03 for every year this investment was sitting. So since it was sitting for 5 years, it's going to be divided by 5. So again, Mr. Price does not know what that is off the top of his head, which is okay. So the actual value of this investment here and the purchasing power that it will have will be the equivalent of $4,373 because that's a pretty high inflation rate at that time. And whenever you all are making decisions for this type of stuff, on whether to invest in doing this and doing that, you can definitely look at the interest rates. You can look at the rates for inflation. Those do work against each other in trying to either make you money or lose you money. So Mr. Price is really passionate about all of this financial mathematics stuff. So if you all have any questions at all, even if it doesn't pertain to stuff that we are specifically going over in class, you are more than welcome to ask. If I know the answer, I will tell you. If I do not know the answer, I will either try my best to figure it out or I will just flat out say, hey, I actually don't know. Typically, this is my favorite unit to teach every year. So if you all have any questions, don't feel like that you're bugging me. Shoot me an email, join me on Zoom. We can figure that out. But that's all I have for today's lesson. I hope you all have a good rest of your week and an even better weekend. Bye.